What's up, everybody? Welcome to today's lesson. It is Monday, and we are entering a new unit called probability. All right. We are going to be using those same skills of proportional reasoning and apply them into this different context. So today, you should be able to know how to apply proportional reasoning into and solve problems involving probability using that proportional reasoning. You should understand that the probability is a percentage of what's going to happen, and its complement, the opposite of that, is going to add up to one whole or 100% of all possibilities. And we'll explain that here in a bit. And then by the end of this lesson, you should be able to say a probability and its complement, uh, what the relationship is between the two. So we're working on probability, basic probability, and the word complement, which we'll go into. So you would write this on your notes, and this is what is called our probability line. Now, probabilities can be expressed as fractions and percents and decimals. And if we look at this probability line, you'll see that it's between 0 and 1. That's because all possibilities when I change, all possibilities lie in between these two numbers, because 0% would be, or if I change these two percents, it would look like this. Let me reduce myself real quick. 0 would also be considered 0%. Point, 50 or 50 hundredths or 5/10 would be considered 50%. Okay, and 1 would be considered 100%. So something could be 0% impossible, or it could be 100% certain. So for example, let's take the probability that the sun will come out tomorrow. And I would say that based on the past, it is almost, if not 100% certain, 100%, which means certain, that the sun will come out tomorrow. If not 100%, it's very, 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 very close. Okay. Uh, the probability that you will flip a coin and it will land on heads or tails. It will land on heads. That is equally likely because you have a 50-50 chance on each side. And then 0%, something that's 0% likely is, let's say the sky will show up green tomorrow. That is 0% likely because we know the sky usually shows up blue. Okay, so it's almost impossible. But nothing can lie out of this spectrum. There's nothing more impossible than impossible, and there's nothing more certain than 100% certain. And so, when we're talking about mathematical probability, not guessing probability like you do with your friends, like I'm 110% certain. No, you're basically saying you're 100% certain. And so, when mathematical probability, everything is between 0% and 100%. Now, we're looking at theoretical probability. Theoretical probability is the theory of probability of a specific event. And so, how we would set this up is uh, we can represent probability through a fraction. We can also change that fraction to a decimal, and we can also change that decimal to a percent. Okay, and so we're going to be practicing those skills as we're going through this, or we could express it as a fraction and then also reduce it to, or simplify it to a smaller fraction, the same fraction but smaller numbers. And so the probability, this says uh, P parentheses event parentheses. This says the probability of an event. P stands for probability, and the P outside of these parentheses stands for probability that an event will happen is equal to, in the numerator, the number of favorable outcomes, what we want, and then the new denominator would be the sample space, the number of total possible outcomes. So it's what we want over the total possible outcomes. So let's look at this in a sense of a die. So let's say we're rolling a 5. All right, we want to roll a 5. Well, what are the total possible outcomes? Well, I can roll in the denominator, it would be the total possible outcomes. So I could roll a 1, a 2, a 3, a 4, a 5, and a 6. So there are 6 possible outcomes, all right? And rolling a 5 is one of those possibilities. So a favorable event, because it says probability of rolling a 5, that event is 1 out of all possible outcomes, which is 6. So it should look like this. The sample space is rolling a 1, a 2, a 3, a 4, a 5, or 6. These are 6 possible outcomes that could happen. And the number of favorable outcomes, favorable is in reference to what we're actually looking for. What's the probability of rolling a 5? Well, there's only one favorable outcome to that specific event, which is a 5. So 6 possible outcomes, one favorable outcome, which creates a 1 in 6 chance of rolling a 5. Or that's 0.16 repeating, or 17%. I rounded that last 6 because it's 0.66, which rounds up to a 7. And so you can have it as 1/6, or if I do top and bottom out and divide these, I get 0.166 or 17%. Okay, so I set this up by saying there's one favorable outcome over 6 possible outcomes. 1 in 6 chance. You have a 1 in 6 chance of rolling a 5. Now let's look at the probability of its complement. So the complement of rolling a 5 is not rolling a 5. Complement, okay? It's not, hey, you look very nice today, compliment. This compliment means when let's say you compliment somebody, that means that y'all are opposites, that whatever they don't have, you have, and y'all are opposites. Y'all ebb and flow together. Y'all complement each other, okay? And in this case, it means the opposite of something happening. So at first we had the probability of rolling a 5, and then its complement would be the probability of not rolling a 5. So let's look at this. So the sample space is still the same because we can roll all of those. But our favorable outcomes of not rolling a 5, which would mean we could roll a 1, a 2, a 3, a 4, or a 6. And so those are 5 favorable outcomes for the complement, which is not rolling a 5. And so this is supposed to say P, not 5. I apologize about that. So the probability of not rolling a 5, P stands for probability, and it's supposed to say not right here, is 5 over 6, or 0.83 repeating, or 83%. So the first one, probability of rolling a 5, was 1 in 6. And then the opposite was 5 in 6. So the probability of rolling a 5 was a 1 in 6. And then not rolling a 5 was 5 in 6. And if I add those together, I get 6 over 6, which is 1 whole. And 1 whole was equal to 100%. And if we look at this in percent form, 1 in 6 is 17%. 5 in 6 is 83%. And so these two, the probability and its complement, are equal to all possible outcomes. Because it's 100% certain that we'll either roll a 5 or not roll a 5. Does that make sense? I hope that makes sense. The reason why both of these, when added up together, equals 100% is because we're 100% certain that we're going to roll one of those numbers. So the probability of 5 is 1/6, and the probability of its complement is 5/6, and all together equals all possible outcomes because we're certain that we're going to roll at least one of those 6 numbers. And so that would be all possible outcomes, the probability and its complement. So let's look at another one. So what is the probability of rolling a 4 or a 5? And I'll give you some time to think about what that would be. So remember, it's the number of favorable outcomes over the number of total possible outcomes, sample space. So let's look at this. So our sample space is still the same. It's 1, 2, 3, 4, 5, 6. There are 6 possible outcomes that will go in our denominator. This is supposed to say 4 or 5. Apologize about that. And the event we want is either a 4 or a 5, which is 2 favorable events. So that would be a 2 out of 6, or a 1/3 if we reduce it, which is also 33.33, 333 repeating, 0.33 repeating, or 33, about 33% if I round it. I hope that makes sense. So now let's go into its complement. So the complement of the probability of rolling a 4 or a 5 would be not rolling a 4 or a 5. So let's look at this. That would be its complement. So the sample space would still be the same, but not rolling a 4 or 5, which means we can roll a 1, 2, 3, or 6. That's 4 favorable outcomes over the total possible outcomes, which is 4 out of 6, or 2/3, or 0.66 repeating, or 67% if I round it. I hope that makes sense to everybody. And so when we look at the probability and its complement and the relationship between the two, complement means they complement each other. They ebb and flow together. They are opposites. So the probability of rolling a 405 and its complement is not rolling a 405. Let's look at that. So the probability of rolling a 405 is 2/6. Its complement is 4/6. And when I add those together, I'll get 6/6. So as a percent, it's 33%. And its complement is 67% chance of happening. And altogether, there is a 100% chance of happening, because when we look at the relationship between these two, there is a 100% chance that we're going to roll either the probability or we're going to roll its opposite or complement between the two. Okay? So I hope you kind of try to see what I'm getting at, is that the probability and its complement are worth 100% of the total possibilities. So here's your vocabulary. I encourage you to pause the video. These are vocabularies that we went over. So probability, the percentage chance that an event will occur, which is between 0 and 1, or between 0% and 100%, which are the same things. Sample space is the set of all possible outcomes in a probability experiment. An event is something that will happen, a subset of the sample space. A simple event, which is one event and finding the probability of one event. And a favorable outcome is what we're looking for, what we want, one of all possible events in the sample space. And then complement is the outcome that is not favorable. So, for example, a favorable outcome will be rolling a 5 when we're looking for rolling a 5. Its complement would be not rolling a 5. Okay, so it's the opposite of the favorable outcome. All right. So I hope you got a lot out of that and you understand how probability works with its complement and that they represent 100% of the total possibilities. And so let me know if you have any questions. I'd look forward to hearing from you and helping you out.